Hello guys, welcome back to Maths on African Motifs. We are on our derivatives, working with question papers on derivatives, which is the differentiation part. So on this question, it was just like the partial derivatives only because this is partial and the applications of the partial derivatives, which is fine. No problem. So this is November 2022 exam that we are given here. So we're given question number 1. All right, so on 1.1, we're given Q is equal to this expression. All right, this is the expression for Q. All right, sorry, which is x plus y like this into the ln of x over y. All right. Then we're asked to show that, okay, x, this is what you're supposed to show, that x by the derivative of Q with respect to x plus y, the derivative of Q with respect to y, is supposed to give us Q. And Q is this part that we are given. So it's supposed to give us this. Okay, so it's fine. Let us check what we can do. From this part here, we are working with a partial derivative. So let us focus on Q first and x. All right. So what is going to be the derivative of Q with respect to x? What is going to be the derivative of Q with respect to x? So if we check, we've got x here, and we also have x here. So that means we are supposed to apply a product. So it's a function, there's a function, and it's also a function there. So we are supposed to apply the product rule. All right, remember from the product rule, it states that you're gonna have u, the first derivative of v, plus v, the first derivative of u, where this is our u and this is our v. All right, we are focusing with respect to x. Our derivative is supposed to be with respect to x. So meaning to say u is just gonna remain as it is, remember? This u remains as it is, which is x plus y in this case. All right, so this is it. The v is we are supposed to have the first derivative of v. We are supposed to have the first derivative, the derivative there of v, and it's ln. So we are supposed to find the derivative of ln x over y like this with respect to x. Take note, it's with respect to x. So it means y acts as a constant. Y is a constant. It acts as a constant. Just imagine you are asked to integrate ln x over 2. 2 is a constant. How do you integrate this? How do you integrate this? Remember, the integral, all right, this before you talk about the integral, this is same as ln half of x like this, half x like this, all right? Remember that the integral of ln is the first derivative over f of x, all right? The first derivative of f of x over f of x, which is the derivative, which is, or you can just take 1 over what? 1 over x. We talked about this. So meaning to say, as we are differentiating with respect to x, we are going to have f of x, all right? The first derivative, which is a half in this case. This will be like this, a half, all right? Over f of x, which is a half of x. So this is the same thing that you have here. This is y, x over y. So instead of you writing as this, it is the same thing as we've got this as ln 1 over y times x like this. So it was going to give us the same thing here, 1 over y over 1 over y times x. And what was going to happen at the end? This was going to cancel. You remain with what? 1 over x. Are we together, guys? Y is a constant, so it acts as a constant. The same way you differentiate if there was a number, that is how y is x, because it's with respect to x. So meaning to say, we're going to obtain 1 over x, all right, from this case, okay? Plus v, the v we are going to take as it is, this of v, which is the ln of x over y like that, as it is, times the first derivative of u is x plus y. So like I said, we are differentiating with respect to x. So with respect to x, if we differentiate here, sorry, okay, I want to remove this. If we differentiate this with respect to x, what is the derivative of x? The derivative of x is going to give us a 1. So that's a 1 plus, what is the derivative of y? Y is a constant. So the derivative of a constant gives us a 0. It's the same as there is x plus 2. You get 1. What about this 2? You get a 0. So it's 1 plus 0. So that is the concept. Y is a constant in that manner when you are integrating with respect to x. That is the part of the partial derivative. You are focusing on x, so y is a constant. Okay? So what we're going to obtain if we just simplify this, this we can just multiply. This is the same as over 1. So it's going to be x plus y over x like this. All right, x and 1 is going to be x, okay? Plus 1 times this is going to be just ln x over y. So you can just leave it like that, okay? So this is the derivative of q with respect to x. So we are going to apply the same derivative like what we did here, but this time of q with respect to y. All right, so meaning to say, when we are finding the derivative of q with respect to y, take note, what is important is that it's with respect to what? With respect to y. So at this moment, take x to be a constant. Here, we were talking about with respect to x. So on our calculation, we had to take y as a constant. So y is taken as a constant. That is what we saw. Now we are differentiating with respect to y. So it means in this situation, x is going to be taken as a what? As a constant. Wherever we see x, we see it as a number. That's what I'm trying to say. Wherever you see x, you see it as a number, just like a 5. So if you do not want to have a problem, just where there's x, put a number there where there's x. Put a number so that you don't have a problem. X is a constant, so you are focusing with what? With y. So if we are focusing with y, here there's y, here there's also y. So meaning to say we are back again to the product. Y is multiplying another y, a function of y and another function of y. So we are still back to the product where we said we're going to use this formula u. So u is going to remain as it is, which is x plus y. So that is going to be x plus y like this, all right? The first derivative of v, this is what we have. We are supposed to differentiate ln, which is ln x over y. But take note, this time we are focusing with y being the one that we are dealing with, being our major focus. X being a constant. X is a constant. X is like a 2. It's like we are given ln 2 over y like this. How do you differentiate? How do you differentiate? This is the same as we put ln 2y to the exponent of -1. Remember the derivative of a ln, you differentiate. Yes, you know that you are going to get 1 over y. If it is a linear, we say the derivative of a linear, if we are given ln ax, if we are given this condition of ln ax, our answer is going to be 1 over x. So if it is ln ay like this, the answer is going to be 1 over y. That is what we can take for a what? For a ln, in an easier way like that. But now let's consider, because we've got the negative that is also considered there. So this is what we are supposed to consider, because it's no longer ay in that manner. There is an exponent this time, ln. Let's take an example like ln 2y to the exponent of -1. From the derivative of a ln, we said we're going to need the first derivative of this function, which is going to be minus, we drop the exponent, which is going to be minus 2y to the exponent of -1 like this. So we subtract 1, so it's going to be -2 over the original function as it is, which is 2y to the exponent of -1. So if we're to simplify this and this cancels, we get a negative. Then we subtract the exponent. So it will be -2 minus 2 minus minus 1, which is going to be minus y to the exponent of minus 1, which is minus 1 over y. It's no longer 1 over y. It is now giving us minus 1 over y. Where is the 2? The 2 cancelled. So it is the same thing if there is an x there. It means the x and the x will cancel later on. If there was x here, we're going to put an x here. This was going to be x. This was going, because x is a constant at that manner. X is acting as a constant. You are focusing on y. All right. So it means here the derivative of the whole of this part of ln x over y is going to give us negative 1 over y. So we're going to multiply with negative 1 over y like this. All right. So that's it. We move on to the other part. We are applying our product. So we are at this stage. So we're going to add plus v. So the v is going to remain as it is, which is the ln is going to remain as it is, ln x over y like this, times the first derivative of u. So you're going to differentiate u in this case, which is x plus y. But x is taken as a constant. So it's like here there's 2 plus y. What is the derivative of 2? It's a 0. So if we take x as a constant, what is the derivative of x? It's going to be a 0. All right. So you are going to have a 0 plus the derivative of y. Since we are focusing with y, the derivative of y, it's what? It's a 1. So it's going to be 1. It was supposed to be 0 plus 1 like this, because x is a constant. So if you differentiate a constant, you get what? You get a 0. So that is the idea there. Just like there's a 4 here, 4 plus y, or 5 plus y, because x is acting as a constant. You are focusing your aspect, your derivative is limited to y. Anything that you see is just like a number. That's what it means. All right. So you can combine. This is negative 1 over y is going to multiply. This will be negative bracket of x plus y like this over y plus 1 times ln is going to remain as it is, ln x over y like this. All right. So this is the derivative of q with respect to y. All right. So with this, I want us now to combine what we got here and what we got here together. All right. They are saying if we multiply by x, this is what we are given because we have differentiated each. So the question is that if we multiply x to the derivative of q with respect to x plus y to the derivative of q with respect to y, we are supposed to obtain q, of which q is this expression. We are supposed to have this expression. Is that so? Let's see. So this is going to be x times the derivative of q with respect to x. We determine this. This is the one that we have here. The derivative of q with respect to x. It is x. We got x plus y like this. I'm just going to open a bracket over x. All right. Plus here we got ln. So this is ln x over y like this. All right. So let us close our brackets. So this is the part that we are having of the derivative of q multiplied to x plus y in this case. All right. So this is going to be plus y times the derivative of q with respect to y. The derivative of q with respect to y is this one that we got, which is minus bracket x plus y like this. Everything over y plus the ln of x over y. This is what we got from this derivative. Okay. So we're going to simplify and see what we are going to have at the end. All right, let's simplify. So if we multiply here, x is going to affect everything. So it's x and x inside the bracket. This x and this x was going to cancel. We remain with the bracket of what? X plus y. So it's going to be x plus y. Then x multiplies ln. So it's going to be plus x, the ln of x over y, like that. All right. The same thing here. Y multiplies this. So it's going to multiply. This is in the denominator, so it's like this. Y and y, they cancel. So we are going to remain with minus the bracket of x plus y. So it's minus, all right, this is like this here, sorry. So it's going to be minus because it's plus and minus. So this cancels. So plus and minus is minus the bracket of x plus y like this. All right, y multiplies also this part. So it's going to be plus y into ln of x over y, like this. All right, so this is what you're going to have at this stage. And if we check properly, we're going to see that this bracket and this bracket are the same. Here we are adding and subtracting, so this is going to cancel with this. So we are going to remain with this part of x, the ln of x over y, like this. All right, plus y, the ln of x over y, like this. This is what you're going to have. So this is from this expansion, remember. And what is it that we see here? If we take a closer look of this part, it is actually similar to this part that we had, only that if you see what happened, they just factored ln x over y out. So this is exactly what we have, because we've got ln x plus y, which is common. And they just factored, so we just have to factor out this. And if we factor out ln of x over y like this, if we factor out ln x plus y here, what are we going to remain with? Because this is the common term that we see. We've got a common part here, ln x plus y here, which is the same as this one here, the ln of x plus y that we see here. So this is what I'm asking to say. If we factor this out, what is it that we are going to remain with? Here we are going to remain with x. Here we are going to remain with plus y. This is the format that they wrote here for us. X plus y in a bracket, ln of x plus y. So this is exactly what we already have on our answer, only that we have to factor out ln x over y. And this part, as we can see, this is exactly our q. That is what our q was equivalent to. Remember, q was equivalent to that expression. Q is equivalent to this part. So that is what the question is asking us, to show that this is equal to q. This whole part here is going to give us what? Is going to give us a q. So that was the part of our question, all right, which is equal to 2. So that is how you can attempt these typical questions. So partial derivatives, guys, it's easy. You just have to understand your normal derivatives from your N5, okay? But also knowing the idea that I'm explaining, to say if you work with the derivative of x, y is a constant, y x as a number. Just like there's a 10, a 20, think of any number of your choice. Just think of any number. That is how that letter is acting at that moment. If you're finding the derivative with respect to y, x is a constant at that moment. So it acts like any number that you can think of. So you can be able to differentiate normally the way that you're supposed to have your derivatives done. All right. On question 1.2, we are given that z is equal to, all right, so this is what we are given here, which is 3 marks for that. Okay, let's just try to see our question properly. So we are given that z is equal to 3x squared y to the exponent of 5. Find the rate of change of z. Whenever I talk about the rate of change, it must be a rate of change with respect to something. We talked about the rate of change in our N5, which is a little bit different from this one that we are going to have now. So these are applications of our partial derivatives, the one that we've been talking about. So there we are given z, and we have asked you to find the rate of change of z, which we can write in short as the rate of change, which is the change in z, the derivative with respect to z. So this is the one that we are being asked on a condition that x is 3 units, when x is equal to 3 units and y is equal to 2 units. While x is decreasing. So it means the rate of change of x is decreasing. All right, we are given its rate of change, which is what? -5. A decrease is a negative, which is units per second. Remember, the rate of change is units per unit time, which is per second. And y increasing, so the rate of which y is affected, it's an increase, so an increase is a positive. So it's 2,5 units per what? per second. It's a positive. So the question is, how can we find the rate at which Z is affected? Is it increasing or decreasing? How do we find it? That is the question. All right, this is the formula that you're going to use if you are dealing with these partial derivatives as a combination. You are going to find this as, since this is an expression for Z in terms of X, and also in terms of what? In terms of Y. So it means the change in Z is going to be affected with the change if that is going to happen, like the derivative of Z with respect to X. So you're going to find the derivative of Z with respect to X, the first variable. You multiply it to the change of X. All right, so this one is the change in X, which is this one that I'm writing here, or you can write it this way, like the change in X, so that you do not have a confusion like this, the change in X, which is this one. Okay, so if this is X, this must be change in X. You move on to another variable still on Z. So Z is going to be affected with what? With Y also. So it's going to be plus the derivative of Z with respect to Y times the change that happens with Y, because Y is changing. So it's going to be times the change of what? Of Y, which is this one. So let us just write like this, the change in Y. That's how you formulate the formula. Whether you're given in terms of volume, there will be two variables there. So that volume is going to maybe change, whereby we're going to see maybe the volume changing in terms of the radius. You multiply to the change of the radius. Maybe that same volume is going to change in terms of the height. You multiply to the change in height, whatever that it must correspond. The radius must correspond to radius. Here is the change in X, so it must correspond to the change in X. Is the effect of Y, so it must correspond to the change in Y. So that is the idea of the question, all right? So once you know the formula and how to use this formula, guys, you're done. So what does it mean? The change in Z is going to be equal to the derivative of Z with respect to X. So this one is the derivative of Z with respect to X. So we're back now to that condition that I was talking about. All right, let me not rush and make you understand. This is 1.2, remember, guys. All right, remember what I said. When you are finding like this, we want to find the derivative of Z with respect to X. This is our Z. Z is equal to 3x squared y to the exponent of 5. So since we want with respect to X, it means Y is a constant. Y is a constant. Y is just like a number, just like 3. How do you differentiate? Let's say you are given 3x to the exponent of 5. You affect X. This, whatever that you get is going to be multiplied, but you focus on X. X is the constant. X is the variable. Whatever that follows at that moment is a constant. So this y to the exponent of 5 and these 3 are the same. They are all constants because we are focusing with what? With X. So this will be 3y to the exponent of 5, which is our constant. So this will be like this. 3y to the exponent of 5. This is our constant, all right, times. Now we find the derivative of X. What is the derivative of X? This will be 2x, all right, because we are focusing with respect to X. So if you differentiate X, you drop the exponent, it gives you 2x. Then you can multiply this and this. If you multiply, it's going to give us 6. So this will be 6 xy to the x. And now you can write in whatever order that you want, but I wanted you to see what exactly it means. So this is going to give us 6x y to the exponent of 5. Whatever that we have, we are going to multiply to the change that happened in X, which is a -5, this one, all right? Plus the derivative of Z with respect to Y. When we are now focusing with respect to Y, it means at that moment, X is now a constant, all right? X is now considered as what? As a constant. Remember, this is Z, which is equal to 3x squared y to the exponent 5. So the part of X, this one, is now a constant. So it's just the same as this, it's just the same as a 3. So the derivative of Z with respect to Y, this 3x squared, is a constant. So it's just the same thing, just like what we had on Y. It's a single term. It's a constant because X is a constant. It's just like a number. It's just like a 5. just like a 7. So what is it that you, if you are given to differentiate 7y squared with respect to y, when you are given a constant, now what do? You leave this constant as it is, you differentiate y, we get 7, y to the exponent of 6, whatever that you get, you multiply. So this is the same consideration, only that this is in terms of x, all right? Only that this is in terms of x. So this is the number that just like a 7, just like a 2, just like a 10, just like a 20. Now we have to differentiate y, which is going to be 5y to the exponent, we subtract 1, which is 4. So you multiply this and this is going to be 15. That's 15 x squared y to the exponent of what? Y to the exponent of 4. So that is it. So you're going to have 15 x squared y to the exponent of 4 times the change that happened in terms of y. So that is it, guys. So that is it. Let us find the rate of change of z. So even here on this z, you can write it as this, the change of z. The change of z is the way that you want, guys. Okay, you can even write it that way. So this is it, guys. 6x. At this stage, we have differentiated everything. What we need is to substitute. That is where we are given these values of x and y, and also the rates of change that happened. So we are given there on the first condition, x is 3. So this is going to be 6 times x, which is 3, times y, which is 2. So it's 2 to the exponent of 5 times the change in x, which is the change in x that happened, which is -5. So that's a -5, okay, plus 15 times x squared. X, remember, is 3, so it's going to be 3 squared times y to the exponent of 4, y, which is 2, to the exponent of 4, times the change in y, which is it was an increase, so you substitute it as a positive. All right, so that was going to give us the change in z. If you simplify this properly, the first one, you're going to get -2880 plus this second part, if you simplify it properly, is going to give you 5,400. So this will give us at the end 2,520. Remember, this is a rate of change. And like I said, whatever rate of change is with the units per second. So this is going to be units per second, or you can just write U per second like that. That is units per second. So that is how we were supposed to attempt this typical question. That is the change in what? The change in Z, the rate of change that happened in Z, and it's a positive, meaning to say Z was increasing on these conditions. Z was increasing. If you obtain your Z as a negative, it means Z was decreasing at that condition. That is how you attempt these typical questions. So as you can see, we just have to be careful with the type of question that you're given, but it will be 6 marks on number 1. Always this, like this guy, 6 marks. Okay, so let's just hope we shall have more questions to work with, or more questions to attempt from our question papers, so that we'll be able to revise them together.